Welcome to Tales at Scale, a podcast that cracks open the world of analytics projects. I'm your host, Rena from Imply, and I'm here to bring you stories from developers doing cool things with Apache Druid, real-time data and analytics, but way beyond your basic BI. I'm talking about analytics applications that are taking data and insights to a whole new level. Now, we know that I have a definite bias towards Druid, but I'm realistic about what it's meant for and what it's not meant for. Every technology has its key use cases and places where it's a good fit and where it's not a great fit, right? But there are some misconceptions about Druid's capabilities. I'll actually be joined by today's guests at Druid Summit this year to talk about them, but stay tuned at the end of the show for more info on that. Back to today's episode, we are debunking a pretty persistent Druid myth, one that keeps coming up. Druid can't do joins. And sure, Druid isn't a relational database, so table joins don't quite work like traditional SQL joins. That's because Druid was designed for fast queries on large-scale datasets, and it primarily focuses on aggregating and filtering data across dimensions and measures. But that doesn't mean that it can't do any joins. It just does them differently. To get to the bottom of this, I'm joined by returning guests, Sergio Ferragut, Senior Developer Advocate at Imply, and Hellmar Becker, Senior Sales Engineer at Imply, and they are my myth-busting team for today. Sergio, Hellmar, welcome back to the show.
Hey, Rena. Thanks for having me back.
Hey, Rena.
So since you're all my first repeat guests, we've already kind of dug into your backgrounds and experience with Apache Druid. You know your stuff. So I wanted you to come back and help me out with this nasty little rumor I keep hearing about. I'd even go as far as to say it's like database trash talk that Druid just can't do joins.
Yeah, that's not right. So Druid can do joins. Druid actually does joins in two different ways. Druid has a concept of lookups, which allow you to do fast joins, in-memory joins. The lookups, well, we'll get into the explanation, and it also does, it also newly does shuffle joins. But we'll get into the shuffle joins in a second. But normally it solves any joins in the broker. So it processes the aggregation and the filtering in the historicals, returns the data back to the brokers, and can process joins in the broker. So Druid can do joins.
Okay, so Sergio, then why does this rumor sort of persist that it can't?
Well, I guess it's because it's doing the joins in the broker, right? So what that means is, it's parallelizing all of the aggregation and filtering that happens in the data layer, right, in the historicals and in the streaming tasks. All of that occurs in parallel. They each return a subset of the results, a partial result back to the broker. And that's where the broker can take multiple subqueries or multiple data sets and do the joins. Problem is it's a single thread. So yes, if you return a lot of data to the broker, it'll take a while to solve that join, right? So yeah, it's not meant for large fact-to-fact joins at query time.
Well, I guess that kind of goes back to like, what is the purpose of Druid, right? Like, it's not meant for certain things. It's meant to be fast.
Right. So yeah, data warehouses and data lakes are very much designed to do large joins, right, at query time. And because they can do that, they can solve a larger variety of fact-to-fact joins. But they're not going to respond in sub-second response times once you have certain large data sets if you have to do that kind of join, right? So yeah, Druid made a decision to optimize the use case where the joins are pre-done, so the data is pre-flattened, so that we can solve queries, large queries in parallel in sub-second response times with ad hoc aggregation, but yeah, without fact-to-fact joins.
So maybe to like fully squash this misconception, we should go back to where maybe it started. So broadcast joins weren't introduced until Druid 14, I believe. But with those, there was still a limit on the scale of the data that you can join. So, it was broadcast joins versus, say, lookups. Can we talk a little bit about those?
Yeah, maybe I can take this one. Lookups are, well, first of all, Sergio just said it. A standard Druid join is good for joining one large set of data against a smaller one, like fact versus dimension. But it happens on the query node, on the broker, and we'll come to why that is in a moment. So this kind of joining data is quite performant, but it's all processed in a single thread, so it cannot really take advantage of parallelism. So what was introduced in order to alleviate that problem was broadcasts via so-called lookups. So lookups are data sets, and you typically want to keep them small. They are kept in memory on every single data server. So each data server has a copy of that lookup table. So imagine you have something like a country list or an address list. So your typically small warehouse dimension would live in such a lookup table. And these are blazing fast, but then again, at the expense of permanently keeping a copy of each of these data bits on all the nodes.
Well, maybe I know we've introduced since, in May, we had Druid 26 was released, and that included shuffle joins. So, Hellmar, can you talk to me a little bit about what are shuffle joins?
Yeah, so as we already hinted, there are still a lot of use cases where you do want to join, where both sides of the joins are too large to fit on a single server, and also too large that you can send a copy of one of the tables to all of the servers because it's just not going to fit. So what you want to do with a shuffle join is you shuffle the input data in such a way that the bits that need to be joined together are cut up into packages, and each of these packages is sent to one server to process. So you have it's like map reduce, where you actually have map, shuffle, reduce. And that is what is now implemented in Druid, and that lets us do much, much bigger joins.
But still, they aren't sub-second at, a certain size, right? And it goes back to kind of the purpose of Druid.
It goes back to the purpose of Druid, and it also goes back to the fact that you can't beat physics. Druid, as you probably know, Rena, Druid was deliberately designed to use a scatter-gather query pattern, where you assume that you are able to cut up your query workload into packages that can be processed each by one server without communicating with anybody else. And that works only if you have one big table. And so it works if all data that one subtask needs is available on the same server. And in order to be able to process general joins, you need to introduce a shuffle phase that puts the right data pieces together. And that comes at a cost, always. Every database system that allows these generalized joins has to pay that price.
Yeah, especially like the larger the data set, the more difficult it becomes.
That's right.
But all this hullabaloo about joins, there are folks who are kind of circumventing them entirely with unions. Sergio, I think you mentioned Target is doing that, right?
Yeah, there's actually, we should link that video in the description here, but that's the Target Druid Summit presentation that occurred, I believe, in 2021. The guy from Target described what they were doing, and they were doing. They prepare the table such that they have the same set of columns, aggregation columns, even though they may be talking about different things, like some is sales data and some is sales forecast data, and others maybe inventory data. But they have the same set of columns that they're aggregating on when they ingest them, so that when they query them, they can query them independently and use a union to present the result, bring the results back together. So it's a pseudo join, right? It's not really joining the data, but it does bring it back together in a single result set and can be used for different metrics from different sources of data. And that's what Target is doing. So it's an interesting way of getting around the lack of fact-to-fact join at query time.
Seeing as though it's Target, I imagine they have a lot of data that they're dealing with all the time.
Right. And the other thing we should mention, right, is with the introduction of shuffle join, it allows you to do that preparation of the data ahead of time, right? Because we still, Druid can now do the shuffle join, right? And you can issue a select to Druid that actually uses a shuffle join, but that is not going to be a sub-second query, right? That's I think we've established that. So the way we're seeing implementations use Druid's shuffle join is to use it for ingestion. So they ingest from multiple sources, potentially multiple external sources, so they may be transforming some data that they've already loaded into Druid. But the point is you can do that shuffle join at ingestion time. You do a batch of processing such that you do those joins ahead of time, so that when you do the queries, you do get a scatter gather and you have all of the dimensions available to do ad hoc analysis on aggregating and filtering on all those dimensions.
You're saying we just have to do things a little bit differently. Not that it can't, it's just a little bit different.
Correct.
Yeah, so basically, I think what you're building then is like a materialized view, right?
Essentially, yeah.
It's very interesting. But yeah, I think that, that's one thing to consider is, why are you using Druid? What are you trying to accomplish in the first place? And there are always going to be trade-offs. However, maybe this is a little bit of like a heated question, but I'm all about transparency. Like, how much slower would it be? It's not going to be like a snail's pace, right?
Well, it depends, right? Hellmar, you want to give a shot at it's going to be an order of magnitude, probably, at least.
Well, we are working with this big telco operator that is using Druid at scale. And I think they are maybe not quite sub-second when they really, they really join all their network data and their mobile data together. And they still achieve a query performance in the range of seconds.
While doing the shuffle join?
Yes.
And this is on Druid?
On Druid, yeah.
Okay, that's interesting. So they're querying.
No, actually, no, they don't do a shuffle join. They do the join on the broker.
Okay, right.
So they have pretty beefy brokers, and that is what they decided to do.
Wait, did you just say beefy brokers? Because I love that. That's going to be another thing from this podcast.
But yeah, and you can do that, right? And you're absolutely right, Hellmar. Let's make sure that people understand that you can do these joins on the broker, and you don't necessarily need an incredibly beefy broker. It helps to have a beefy broker for sure, but the point is that you design your queries such that they're not returning, billions of rows to the broker to do the join. They're returning, maybe hundreds of thousands, right? And you could still still do something fast. But yes, the join on the broker is a bottleneck that you need to design around, right? You need to think about it.
There is a lot of considerations that come into play. If you come from a more traditional background, you think in terms of a relational database, and then you will find yourself often to rethink a few things, and then all of a sudden it becomes easy in Druid. Just don't stick to your old terms.
Right, and you shouldn't probably do that with open source tech anyway, because things are always changing. Or if you're working with us at Imply, like there's always new versions. The community is always working to improve things, make them as fast as possible. So if you're still doing the things the old way, then that's on you. Not to call anybody out, but that's kind of on you.
Yeah. So yeah, I guess one of the things we can conclude on is yes, Druid does require that you, like Hellmar says, think a little different. And that you do the modeling work. There is some modeling work to do. And, you need to think about what kinds of patterns of queries you want to solve and with what response times. And you build the data structures in Druid that will support those.
Well, come to think of it, Sergio, you also have this rich experience in RDBMSs, right? And what you often don't think about is how much mental work goes into designing your relational data model to do proper joins, because you spend a lot of time figuring out how to partition your data, which kind of indexes to put on both sides of the join in order to make them really perform well, because otherwise your relational database is also going to suck at joins, right?
Right.
It's just that because the ways that you think out these things in Druid are new, sometimes makes them stand out more. But in the end, these are cycles that you need to put into proper planning with any
Right.
system.
I love a good planning cycle, let me tell you. Okay, so to conclude, Druid can do joins. It just does them a little bit differently.
Absolutely.
All right, I think we squashed that, guys. I think we have it. This is here, so if anybody has any questions, we can just point them in this direction. Hellmar, Sergio, thank you again for joining me on today's show. As I mentioned in the intro, we'll be doing a whole session demystifying Druid myths at Druid Summit 2023, taking place on December 6th. We'll actually show you how Druid does joins, updates, and more. Registration is now open on druidsummit.org. In the meantime, if you want to learn more about Apache Druid, please visit druid.apache.org. And if you want to learn more about what we're all doing here at Imply, please visit imply.io. Until next time, keep it real.